Now we're going to do a compound interest maturity value problem, and for this we're going to use a different tool on the calculator, not solver but a special one called TVM solver. You want to press the apps button. If you don't have an apps button because you have a TI-83, you're going to want to look for the finance key. It says finance and it's going to be under the second key. So either apps or finance. Okay, I'm pressing apps because I have a TI-84 silver. And I'm pressing enter to finance, which is the very first one. Yours is going to be slightly different if you have an 83, but eventually you're going to get to the one that says TVM solver, and you want to press enter and load that. Okay, so let's notice a few things here. N is going to refer to the time. It may actually be the actual time or the number of periods, depending upon how you set this thing up. I is the percentage. Here in this case, we're going to put in the actual percentage, not the decimal equivalent. PV is present value. PMT is payment. It's not going to be used in this problem. FV is the future value or the maturity value. P over Y is the payments per year. That's not going to be used in this problem. And C over Y is the compoundings per year. So, and N refers to the payment, also not going to be used in this problem. All right, so let's see. We have this amount is the principal, or the present value, $12,903.45. So I put $12,903.45 in for the present value. I got to put 6.37% in for the interest. The future value we're going to calculate, that's not known. And we want compounded quarterly, which means the compoundings per year is 4. That's quarterly. All right, so pay attention here because there's two ways to do this. One, I could leave the payments per year at 1, and in which case up here goes the actual number of years. So we're supposed to do this for 29 quarters. So I can do 29 divided by 4 and get 7.25 years. In which case I can do alpha, just like the solver, alpha, solve, enter, and I'll get 20,402, which is this number that I got right here, okay, for the maturity value. But there's an alternate way to do it, which is if you set the payments at the same number, which will be the case when you start doing annuities, for example, then you're forced to put in the number of periods up here. And in this case, they gave it to us, 29 quarters. So I put 29 in, and I go back down to future value, and I press alpha, enter. Notice how I get the same value. So be clear on this. There's possibly two ways to do this. When you are working with payments, you don't have any choice. You have to do it this way. When payments are not involved, you can put the actual time in years under the value n, as long as p per y is set at 1. A couple other things to notice, at least one other. The future value and the present value have opposite signs. This is a counting deal. It's not an incorrect minus sign. So talk to your accounting professor. They'll explain why there has to be a minus sign there. But in any case, if you put the present value in as positive, the future value will come out negative, which is going to be the difference between the future value and the present value. And we're also going to be tricky. We're going to go into the future value line, and then I'm going to hit the delete key until I'm down to the pennies. And because the future value is negative, I'm actually going to add back in the present value, 12,903.45. And if I scroll up, it'll do the arithmetic for me. And there we should be. The answer is 7499.53.